Today we are going to learn number systems. Now, how the number system came into picture? Just a quick recap. So, what is a natural number? Natural number is all the number that we face in real life. So, anything like 1, 2, 3, 4, 5, 5 bananas, 4 trees. So, in real life, whatever is the type of number that we face is the natural number. Now, in this, when we add 0, it becomes whole number. So, whole number is natural number plus 0. Integers, when we add negative to this, so -1, -2, -3, and then all the whole number 0, 1, 2, 3, 4. This is this is this is integers. Sorry, not rational number, integers. Now, what is rational number? Now, if I look between 1 and 2, this is 1, this is 2, there are a lot of numbers in between, like 1.5, 1.7. So any number that can be expressed as a fraction. So all the fraction are parts of rational number. So like 1.5 is 15 by 10, 1.7 is 17 by 10, or half, 1 by 2, or 3 by 4. All these are rational numbers. Rational number. Now, what is irrational number? Irrational number are the numbers which cannot be expressed as a fraction. So, square root of 2, square root of 3, all these are irrational number. And then sum of all rational plus irrational number is real number. So, all the number put together is real number. Let's look at it again. Natural number, all positive integers 1, 2, 3, 4, 5. These are natural number. Add 0 to it, it becomes whole number. Add negative numbers to it, -1, -2, -3, it becomes integer. Add fractions to it, so like between 0 and 2, half, 3 by 4, it becomes rational number. Add the numbers which cannot be expressed as a fraction, like square root of 2, square root of 3, it becomes irrational number. Sum of all this put together is called real number. How to remember it? Just remember the mnemonic: numbers with intelligence rule in reality. Numbers with intelligence rule in reality. So numbers n is natural number, natural. With w is whole number. I is integers. R is rational. I is irrational. And then reality, R is real. Numbers with intelligence rule in reality. First is natural number. Add 0 to that, it becomes whole number. This W. Add negative to it, it becomes integer. This I. Add fractions to it, it becomes rational. And then irrational numbers, all put together is real numbers. Natural, whole, integer, rational, irrational, real. Number with intelligence rule in reality. Now the examples: 3, naturally it's a natural number. 0 is a whole number as we saw here. -5, it's an integer because that's a negative number. 2 by 3, fraction, rational number. Square root of 2 is irrational number. Now let's take some other color. So what is rational number? As we saw, rational number is nothing but rational number is ratio. Any number which can be expressed as a ratio in ratio of P by Q. So half 1 by 2 is a rational number. 3 by 4 is a rational number. 17 by 3 is a rational number. When we convert this rational number into decimal points, it can be repeating or non-repeating, like half. Half is 0.5. Now, if you do 1 by 3, if you divide 1 by 3, the result will be 0.333333. It will never end. So 3 keeps on repeating. So that is also rational number. If a number after decimal keeps on repeating, it's a rational number. -7 naturally is a rational number. It's an integer, and integer are part of rational number. So -7 is a rational number. 0.272727 naturally is a rational number because 0.27 is repeating again and again. So it's a rational number. So rational number can be expressed as P by Q. Rational number is ratio and it will be either terminating. So after decimal, after few points in decimal, it will end, or something will keep on repeating like this 0.27, 0.27, 0.333 is a rational number. What is irrational number? Irrational number is a number which is irregular, like there is no end, there is no pattern. So square root of 2, if you look at square root of 2, it is 1.414213, and if you keep finding the square root, you will never find a pattern where the numbers are repeating like 0.3333. That kind of thing will not happen. Square root of 3, same thing, you will not find a pattern, it will keep extending after decimal point. Pi, similar number, it will keep expanding after decimal point. So all these type of numbers are called irrational number. Rational plus irrational number put together becomes real number. Now plotting number on a number line. So you know the number line, right? Number line looks something like 0 in the middle, then 1, 2, 3, and so on. And on this side, -1, -2, -3, and so on. Now, if I have to plot any number on the number line, so I have to plot 1 by 2. 1 by 2 will be between 0 and 1. And 1 by 2 is half of this. So it will come in between this, exactly half. 3 by 4. 3 by 4 is again between 0 and 1. How I will plot that? I will find out 3 by 4. It will come to 0.75. So I will divide this 0 to 1 into 10 parts. So this is 0.1. So I will take, this is 0, this is 1, in between come 0.1, then 0.2, like this, 0.3. I will divide it into 10 parts, 0.9, and then this is 1. Now I have to find out 0.75. So I will take points. So let's say this is 0.7 and this is 0.8, 0.8, not 0.8, 0.8. So again, 0.7 and 0.8, between these 2 points is exactly in between that. So I will divide this portion into half, and this is 0.75. So first 0 to 1 divide into 10 parts, find out 0.7, find out 0.8, divide that into half, that is 0.75. So that's how we can plot rational number on the number line. But problem becomes difficult when we have to plot a irrational number. Let's say we have to plot square root of 2 on a number line. How we will do that? We don't know anything about square root of 2. How much is that? Because square root of 2 will keep on repeating. So what I will do, I will take help of geometry. What does geometry say? Geometry, we know Pythagoras theorem, right? So in Pythagoras theorem, if we look at a triangle, right angle triangle, and if the perpendicular sides are, right angle sides are 1 unit, then what would be the hypotenuse of this triangle? It would be, we know A, B, C. So C square equal to A square plus B square, right? So 1 square plus 1 square, that is 2. So C would be equal to square root of 2. So this hypotenuse would be square root of 2. So what I will do, I will draw a triangle, 1 unit length both side. I will take the size of this hypotenuse, so from here to here, and I will plot. I will, from scale, I will take this side, from 0 I will go to this, and I will take the exact that length which is equal to this side and plot it here. It will cut this number line somewhere here, and that becomes square root of 2. So for plotting anything, we have to find this kind of, we have to take help of geometry like this, right? Now the last part, exponents. Exponents, the simple formula that we need to remember is, if exponents we have to multiply, what we do is we add the power. If we have to divide exponents, we subtract the power. If we have to find the power of a power for exponents, we have to multiply them. Let's look at it by example. Here what we are doing, we are multiplying. So what we have done, we have added the power. Base remains same, we will add the power. Here what we are doing here, we are dividing. So what we'll do, base remains same, we will subtract the power. So if we have to divide, we will subtract. Now power, a to the power m. And what we have done, we have multiplied the powers. Rest, whatever formula you are looking at, this is just generic exponents. You might have already heard about it. A to the power 0 is 1. If there is a negative power, it becomes 1 by that power. If there are two base numbers, that power would be a to the power n and b to the power n. If there is a by b to the power n, a to the power n divided by b to the power n. So these are general exponents operations. What these three is what we need to remember. If we have to multiply with same base, we will add the power. If we have to divide, we will subtract the power. If we have to find the power of a power, then in that case, we will multiply the powers itself. Let's look at it quickly. 2 to the power 3 to the power 2, what we'll do, we'll multiply these two power 3 and 2. So 2 to the power 6 to the power 6 is 64. 5 to the power minus 2. 5 to the power minus 2 is nothing but 1 by 5 to the power 2 is 1 by 25. 9 to the power half. 9 to the power half is nothing but 3. 9 is 3 square whole to the power half. That would become 3 to the power 2 into 1 by 2. That is equal to 3 to the power 1. So the answer is 1. 3 to the power 4 into 3 to the power 3 divided by 3 to the power 3. So first what we'll do, we have to do this multiply operation. So 3 to the power 4 plus 2. We'll add the power divided by 3 to the power 3. Now we have to, since this is division, so we have to subtract the power. So 3 to the power 4 plus 2, 6, minus this 3, minus 3. So net is 3 to the power 3. 3 to the power 3 is 27. I hope exponents is concept is very much clear to you. Now let's do a quick recap. First thing, number with intelligence, rule in reality. Just remember this, number with intelligence, rule in reality. N is natural, W is whole, so natural plus 0 is whole. I is integer, so natural plus whole, natural plus 0, which is whole, whole plus negative number is integer I. R is rational number, so in integer when we add the p by q format, which is fractions, then it becomes, all that becomes rational number. The number which cannot be expressed as p by q is irrational number. Add rational plus irrational, that is equal to real number. Number with intelligence, rule in reality. Rational number can be expressed as a ratio. Irrational number is irregular. It cannot be expressed as a ratio. Rational number, either it will stop after few decimal points or it will keep on looping, which is keep on repeating. Irrational number, it will go void, it will never end. And in terms of exponents, if we have to multiply two exponents, in that case we'll add their power. If we have to divide, we will subtract their power. If we have to find power of a power, in that case we will multiply their power. All this operation happens only when the base is same. So 2 to the power 2 plus 2 to the power 3. In that case, we can add the power. 2 to the power 2 plus 2 to the power 3. We can write that as 2 to the power 5. But if it is 2 to the power 2 plus 3 to the power 3, we cannot write this as 5 to the power 5, or we cannot write it as 2 to the power 5, or we cannot write it as 3 to the power 5. This is not correct. This is wrong. Okay. Now, quickly, is this a rational number or irrational number? Naturally, it's a after decimal point there is a number, so either it will be rational or irrational. Now there is no pattern which is repeating here. 10, then 100, then 1000, then 1. After that there might be 4 zeros. So there is no repeating pattern, so it's a irrational number. 3 to the power 4 plus 3 to the power 2 divided by 3 to the power 3. Very simple. 3 to the power first will add, so 4 plus 2 6 divided by 3 to the power 3. So 3 to the power 6 minus 3, which is 3 to the power 3, which is equal to 27. Square root of 5, how we will plot on the number line? We already saw that. We'll take a triangle. Now in this triangle, this should be 5 square, right? Hypotenuse. So 5 square, how it could be? 2 square, one side is 2, this side is 2, this side is 1. So a square plus b square, this is a, this is b. A is 2 square plus b is 1 square. That is equal to, this becomes, sorry, this becomes 5. So hypotenuse is equal to 5. Hypotenuse square is equal to 5. Sorry, let me just repeat this part. What we already saw, we'll take help of geometry. So we draw a right angle triangle. This side is 2, this side is 1. This side is my hypotenuse. So h square will be equal to 2 square plus 1 square. 2 square is 4 plus 1 square is 1. H square equal to 5. So h will be under square root of 5. So I will draw a right angle triangle with one side as 2, another side as 1, the perpendicular sides or right angle sides. So the length of hypotenuse would be square root of 5. I will measure this length on a scale and plot it on the number line. Clear? Now evaluate 2 to the power minus 2. 2 to the power minus 2, as we saw in exponents, is equal to 1 by 2 to the power 2, that is 1 by 4. So that's the final practice. So that's more or less takes care of the entire number system. Now, always remember in maths, there is nothing called learning the concepts only. Learning the concept doesn't help. You will forget it after couple of days or maybe after couple of hours itself. So in 15 minutes, whatever you have learned, you have to practice that. And how you are going to practice? There is a practice set 1, easy level. This 10 question you should solve just after this class. Don't even wait. Pause the video, solve this question and write the answer in the comments. If you don't do that, the entire last 15-20 minutes, whatever you have spent, will go for a waste. So do that right now. And those who are even more interested can do this medium level questions. All the participants who are able to answer all 10 questions in this medium level should consider that they have already become expert in number system, or they already have grasped the concept of the number system. Becoming expert is a different thing. So all these 10 questions, you try that and write the answer in the comment. This would be your final. Then only you can say that I have finished the number system. So in 15 minutes, you have learned the concepts. You spend another 30 minutes, 1 hour to brush up that concept and solve all the questions, write the answer in the comments, and then only you move away from number system.